Hey, you're listening to Reengineering Radio. This episode is going to be a little different. To round out our first season, we'll be highlighting some of the biggest news hits featuring research happening at Michigan Engineering. My name is Jocelyn Reinert. I'm here with some of the Reengineering team. Zach Robertson, producer.
Hi.
Nicole Cassell-Moore, news director.
Hello.
And Levi Hoopmacher, associate producer.
Hey.
Levi's going to kick this discussion off with our first story, coming from U of M's Aerospace Engineering Department, where Ella Atkins' lab is doing some innovative work with drones.
So Ella Atkins is a professor in the Aerospace Engineering Department, and her lab, called A2SYS Lab, is doing a lot of cool work with drones. Most recently, they did a drones and wildfires competition over the summer where they used teams of drones that fought wildfires and could assist firefighters, let's say out in California. But over the summer, one of her grad students, Matt Romano, took a drone and decided to attach a nail gun, and it was working autonomously. So what it did was they created this software for the drone that knew exactly where to put these nails in a roof. And
well, so it was able to, while it was holding the nail gun, it was able to fly over a shingle, find the spot where you drive the nail, and actually hit that spot and move over to the next spot in the strip, all within like a single motion without needing to come back down. So it was able to move from point to point really accurately.
Yeah, and they had to create this software that was able to do that, all the while being able to compress the nail gun so that way the drone wouldn't like flip over or crash when it was nailing it into the roof, which is pretty cool.
Right. Jocelyn, I know as part of the YouTube team here at Michigan Engineering, you saw a lot of the feedback to this video. Can you kind of talk to us about how people responded to this research?
Yeah, this video was posted on Michigan Engineering's YouTube channel. It received so far nearly 200 comments, ranging from concerns about the safety of drone accessibility, apprehension about this kind of technology replacing roofers or members of other workforces that could be that autonomous technology could be integrated into, and also some comments about the impracticality of technology like this.
Levi, I know you saw some of that commentary as well. Do you have anything to say about the use of drones as a way to replace workers? Is that something that this lab is actually aiming to do?
So I don't think that's something that they're looking to do. Like you said, it's more of an experiment. Ella had a good quote, which was, she said, "For me, the biggest excitement of this work is in recognizing that autonomous, useful physical interaction and construction tasks are possible with drones." And so I don't think it's looking to take jobs away, but I think it's looking to assist humans, in jobs where it might not be safe for them to actually be doing work. So they have to climb way up high on a windmill and like heat up some ice to take it off of the propellers so they could, spin them for wind power or, assist them in other areas.
Gotcha. Nicole, is there anything in terms of the work that Ella's been doing with this and then kind of going backwards? Is this just another experiment that Ella's been doing?
It's my understanding the goal with this research was to demonstrate a drone interacting with its environment. I mean, drones are really good at inspecting things right now, photographing things, taking video. But in terms of actually, like I said, interacting with the environment, that's sort of an important next step. And that's really where Ella was focusing with this research.
Got it.
Does that answer your question?
It does. It does.
Ella also had another good quote talking, because there were a lot of comments on there saying, like, 1 year later, the house's roof finally gets finished. I think that was the top comment. And she had a good quote that said, "A novice roofer who's never climbed on a roof, who's never used a nail gun, they start out slow. The learning process, the evolution from them being a complete novice to being successful is something that we'll need to see in the system as well." So similar to like this drone with a nail gun on it is kind of just like a baby learning how to walk. Like it's going to take time to get these systems to where they need to be, to where they're actually assisting humans like on a everyday basis. So if you look at the news, I mean, almost every day or at least a couple times a week, you can see stories of, different countries or nations or regions shutting off, parts of their internet.
And we found that Roya Insafi, an assistant professor in the Computer Science and Engineering Department, and her group, Censored Planet, has been really integral in identifying these instances, right?
Yeah, absolutely. Yeah. So her whole lab is kind of dedicated to this, isn't it, Nicole?
It is, yeah. She's developed a way to monitor censorship without being physically in the country. And that's important because other ways, you have to, a lot of the times when people do this kind of work, they rely on volunteers in the countries to try to get to certain websites and then report back what's being censored. But that's apparently not really, well, that's not always safe for them. So Roya's developed, like I said, an automated way that she can remotely sort of ping different servers in those countries, and she can get a really good picture of what's being censored and where.
Right.
Just recently, she published a paper that showed how Russia has been able to impose a highly effective censorship regime across thousands of disparate privately owned internet service providers. And that's really scary, actually.
Because people thought you couldn't do that, right?
Exactly. They thought that, sure, if you're China and the government controls the whole internet, you just, turn it off or you can control it all. But this is, like I said, thousands of different ISPs that Russia's been able to, coordinate with them.
Yeah, I mean, it's definitely interesting to watch because, like you were saying, when there's thousands of different ISPs, it seems almost impossible for one single government to regulate what gets shown on all of those different access points. But that has some translations that have people in the United States a little bit nervous, right?
Yeah. With net neutrality, that opens the door for ISPs to have a lot more control about the traffic going across the web. And Roya said that sort of control was a key piece of how Russia has been able to do this over the past decade.
And they did it pretty inexpensively, too. The government found a way to crack down on these thousands of ISPs across an entire country for a couple thousand per tool they used?
They were called inexpensive commodity pieces of equipment.
So the key here is that Russia pretty easily and pretty inexpensively managed to censor the internet from their citizens using a decentralized internet service like the United States has.
I want to read you this quote from Professor Ansafi about this work. Russia's rise to prominence as a censor is a wake-up call for censorship researchers, journalists, activists, and citizens of the global internet. So this is a problem not just for Russia, but for nations across the world.
So Levi, I kind of want to go to you for one of the news clips you're responsible for. It involves a researcher you know pretty well on campus, Justin Casper. Can you talk to us a little bit about his work this year?
Yeah, so Justin Casper was the PI of a system of instruments called SWEEP, which is the solar wind electrons, alphas, and protons. And basically what that does is it will count the electrons, protons, and helium ions. And it will measure their properties such as velocity, density, and temperature. And so that launched last year in August of 2018. And so the reason why it's big this year is that they're just starting to get the results, which is pretty cool. And so the Parker Solar Probe is going to cross this point in the solar atmosphere called the Alphane point. And this is the point to where basically the solar wind starts to escape the solar atmosphere. And within this region, it's just filled with a ton of ions and protons and electrons just kind of going crazy inside. And it's kind of weird because the temperature gets hotter the further away you get from the surface of the sun. And so that's one of the mysteries that they're trying to figure out with the Parker Solar Probe. And that's one of the mysteries that they're going to find out pretty soon, actually.
Yeah. Parker, and I think as far as I remember, Parker's a 7-year trip altogether. Is it a decade?
So when we talked to Justin Casper about this, there wasn't a real specific timetable. It's going to be 7 years until it hits its closest approach to the sun, which is going to be the closest man-made object that's ever been to the sun. And so basically it'll just keep on orbiting around the sun using the Venus gravity assist as the fastest man-made object also in the solar system. And it's going to, at some point, the fuel will stop spinning it to where it's facing the sun, and it will just turn around to the backside that's not able to. And
it just bursts into flames, right?
Yeah, it'll basically burst into flames, and the only pieces that will survive will be Justin Casper's Solar Probe cup.
Faraday cup.
Yeah, the Faraday cup, and the heat shield.
Yeah, and last I talked to him in the summer, he was like, yeah, it's just going to be a molten ball that just is stuck in this orbit getting wrapped around Venus, which is kind of wild.
Yeah.
And so I think one of the most interesting things around this is just how much, I mean, Justin had said that the team is expecting a lot of data out of this, but so early on, he said that he was surprised by just how much they've had. So there's kind of a wealth of knowledge around Parker, and I think we're going to be seeing it for a couple years.
Yeah, I would say that.
Yeah, it's and I think they're going to be releasing some findings pretty quickly here.
Like before 2020? Maybe?
Yeah, actually before 2020.
Wow.
Did you know that?
That's exciting.
December 4th, as a matter of fact.
Okay.
So maybe we'll do a follow-up.
Okay, Nicole, our next story focuses on a group of U of M researchers that are working to help autonomous cars predict pedestrian movements.
Yeah, so this was a really cool study, and it was covered in Popular Science and some other outlets. Let's see, Matthew Johnson Roberson and Ram Vasudevan, some of our leading autonomous vehicle researchers, developed a way to essentially teach self-driving cars how to recognize and predict pedestrian movements with a lot greater precision than current technologies are capable of. And, I mean, I don't know if you've ever accidentally walked into the middle of the street while looking at your phone. I've seen people do it. This is the kind of thing that they want to be able to predict. Autonomous vehicles are getting better and better at recognizing what's happening from the other cars on the road. And I think, but there's some other important things they need to get better at. And pedestrian movement is one of them.
Yeah, like one of the big things they talked about with this research when they shared it was like there's often this dance that happens between people who are driving cars and then distracted walking pedestrians that will walk out in front of cars where like both people gesture for each other to go, and it's like this really awkward social thing. And then as we move into a future with autonomous vehicles, that conversation that's like this two-way awkward thing stops, right? When there's no one to drive, there's no one to really signal for you to like keep walking or not. So we need to develop smarter cars that can basically read what these pedestrians are doing. Pedestrians who are often, like you said, distracted, playing on their phone, checking Twitter, whatever, right?
Yeah, exactly.
And this technology was tested actually on the University of Michigan's campus, right? I think it was parked in a pretty busy intersection on South Campus or on South U.
Right.
Packed with students all day, every day, walking, probably on their phones, changing songs, looking at books or their bags or whatever they're carrying. So it was a good test bed for these cars.
And Nicole, wasn't it like didn't have a pretty good read on people from a pretty far distance?
Yeah, so they could predict poses and future locations for one or several pedestrians at up to 50 yards from the vehicle. And that's about the scale of a city intersection.
So everybody loves robots, and a lot of people know that the University of Michigan has a special bipedal robot called Cassie. And Cassie Blue, thank you. And this past winter, there was a polar vortex, and Jesse Grizzle, where Cassie kind of hangs out in his lab, he decided that this was kind of an opportunity for he and his students to test how Cassie could withstand the harsh conditions of the winter.
Right. So while the rest of us here in Michigan were huddled trying to stay warm during the polar vortex, he and his research students went outside to kind of put Cassie through some tests. And all told, they ended up keeping the robot out there for like an hour and a half, which was a pretty big deal. The longest any robot had been outside in these cold conditions and lasted on a single battery. I think it was about an hour and a half, and I think it got some recognition for that. Isn't that about right?
Yeah, so Cassie is now in the Guinness Book of World Records, and the record she holds is lowest temperature endured by a bipedal robot. And it was the day that they took her outside, January 30th, 2019. It was negative 22 degrees Celsius and negative 8 Fahrenheit.
Wow. Yeah, and the team even wanted to put a little scarf on Cassie, but they decided against it because they thought it might interfere with some of the results they were collecting, which is kind of adorable.
It'll be fun to see what they have planned for Cassie in 2020. They're always, they had it walking through fire.
They've done hot, they've done cold.
Yeah.
What's next?
Underwater, maybe. Who knows?
Ooh, Wavefield.
So this research is actually pretty integral in trying to figure out, how batteries in electric vehicles or other electronics can survive, in cold temperatures and last.
Yeah, you're exactly right, Levi. Another one of our researchers, Anastafanopoulou, also had research in Wired this year during the polar vortex about trying to get the most out of your electric vehicles in this cold. And with climate change, as we see more extremes, we're more likely to see these cold temperatures. So learning to get the most out of our batteries in weather like this is going to be crucial.
Our next story is about a computer chip called Morpheus, featured in MIT Technology Review.
So this is some work being done by computer science and engineering professor Todd Austin. It's really, really innovative. What he's developed is, well, he calls it an unhackable computer processor. The way Morpheus works is it encrypts and randomly reshuffles key bits of its own code and data like 20 times per second. So Professor Austin is approaching security from a hardware perspective, and that's really different from this software patch regime that we're in nowadays. One of the things he told us was today's approach of eliminating security bugs one by one is kind of a losing game. People are constantly writing code, and as long as there is new code, there will be new bugs and security vulnerabilities. But with Morpheus, even if a hacker finds a bug, the information needed to exploit it vanishes like literally 50 milliseconds later. So he calls it the closest thing ever to a future-proof secure system.
And to show off the chip's capabilities, Austin and his colleagues went to the ACM International Conference, where they basically demonstrated the work, and then as DARPA-funded research, the DoD is obviously interested in it. So it looks like we're going to be seeing a lot of Morpheus around in the future, I guess.
When the professor talks about this chip, he describes it as like, imagine if you're trying to solve a Rubik's Cube, and every time you turn it, like the squares change color. So it's just like that's the kind of like unsolvable puzzle that he's turning the chip into.
So imagine you're sitting at home and your kids are in bed and you're watching some TV, and all of a sudden your lights go off and the garage door opens and you have no idea why.
Yikes.
Yeah, that sounds kind of terrifying, but researchers from U of M just found a huge vulnerability in Alexa, Google Home, and Siri that allowed them to point a laser straight into one of these devices and mimic the action of talking.
So I think they're using like actual telescopes to like condense this dot and hit these like Google Homes and Alexas, right?
Right. And by super focusing the laser, they were able to mimic the waves of people talking. So they could basically trick these devices into thinking that someone had just told them to, for example, open the garage door or turn off the lights. So it was this huge vulnerability risk. And they demonstrated it here on campus from the bell tower down like 4 flights and across the road at a different device sitting in a window to demonstrate it, which was pretty impressive stuff.
Impressive and scary, kind of.
It is obviously terrifying. And one of the things here is that for years, cybersecurity experts have been saying that these devices pose a huge risk to you. And this is just one more vulnerability that people hadn't really been thinking about. So just another reason to be a little bit nervous about these digital assistants.
So do they have any advice for anyone who has some of these devices and how they might keep themselves safe from laser pointers and flashlights?
At this time, the researchers have notified companies that could be at risk here. But more than anything, the researchers on the team have said the obvious, which is just keep those digital assistants out of the window. Back in the spring, there was a story from one of our graduate students, Noah Furbush, who has basically played a part in this research where they discovered how VTOLs, vertical takeoff and landing vehicles, in the future could one day actually be more efficient than the cars we're taking today to work. The core of the research is basically that these systems would be really effective for people who are commuting long distances. So people who are traveling more than 62 miles to work, it becomes more efficient than cars. So the idea is that in the future, as the populations grow, areas will become more condensed. And as there's more population condensed, we're going to have to move out further from our cities. So in a future where we have these takeoff vehicles, we could potentially lift off from our house 75 miles away and be at work in like a matter of minutes. And it's really efficient to do it, which is pretty cool. Some of the numbers I saw...
They weren't always more efficient,
No, not
right?
always. No, not always.
When, would you remember, like, when did it make sense and when would it not?
So the big thing with these is that they're really efficient when they're up in the air, but liftoff and landing are actually really, really costly on energy. So if you do not live like a greater distance from your place of work, it just doesn't make sense for you. They also found that people who use electric vehicles would probably have similar, at times, efficiency.
And I think the future isn't that far off, because we recently saw in a news article that Uber is starting to test out some of these VTOLs with like something called Uber Air, where they're literally taking passengers from point A to point B in some test cities. And I think they said by like 2023, they hope to have it from city to city and like state to state.
Yeah, exactly. And that's basically how they did this research, is they looked at all these companies who are doing this experimental work, and then as they do that, they're trying to collect the free public access data from those companies so they can try to figure out, okay, what is the energy usage from these? So that's the only way to do it right now.
Over the summer, there was a lot of news coverage about some findings that 6 East Coast cities are emitting 9 times more methane than the EPA thought they were. Washington, D.C., Baltimore, Philadelphia, New York, Providence, and Boston are the cities. And this is really important because methane is like a really potent greenhouse gas, a lot more potent than
CO2.
Than carbon dioxide. So it's not one you hear about as much as CO2, but it's one that we really need to be paying attention to and figuring out how to limit as we try to mitigate climate change.
Yeah, and like that's one of the things he points out with the research is that it isn't something that's going to harm people living in these big cities that have these leaks. But overall, this amount of methane does contribute to climate change, especially because it is much more potent than CO2.
Yeah, I think one of the articles said it's not like people are at risk of like gas explosions in their homes. But that said, it was interesting. Leaky pipes and inefficient appliances, he thought, are major culprits.
Yeah, and I did kind of wonder, just because some of these cities are so historic in the nation's history, I do kind of wonder if this definitely is part of like an aging infrastructure problem here in the United States.
It very well might be. And I think one of the key things that the research can lead to is policymakers and I think scientists need to figure out, like, how do we stop these leaks? It's a big problem, the fact that there's more methane in the air than people can account for. And what Eric Court was the researcher here that was involved in these latest findings. He focuses on trying to identify where the gas is coming from, where this extra methane is coming from.
And Eric Court is actually going to be doing some of these field tests next year, I think in August through October of 2020 with his students, which is a really cool opportunity for them to go out and actually take samples. What they're going to be doing is they're going to be flying really close to the ground in a few areas, like Gulf of Mexico, looking at offshore oil and gas emissions, natural gas flares in Texas, and also greenhouse gas emissions along cities through the East Coast. So that's a really cool opportunity for like his students and his group to get hands-on research and hands-on data back and fighting this climate change and
really trying to pinpoint where is the problem. I think that's a key piece of figuring out how to solve it.
Yeah, absolutely, Nicole.
And so this is just another example of how University of Michigan researchers are leading in their fields, from climate change and energy to national security and robotics. It's definitely been a huge year for Michigan engineering researchers.
Hey, thanks for listening. And if you've been tagging along through this whole journey, we really appreciate it. Just a reminder, this is the end of the first season of Reengineering Radio. We'll be taking a short break, but look for us again in 2020.